Hello, everybody. My name is Kuassi Mensah. I do product management for all the Java products for the Oracle database.
And I'm Michael McMahon. I'm a programmer. I work on Oracle JDBC and Oracle R2DBC.
Okay, this is the session taking your code from synchronous to reactive with an open source project. This is our safe harbor statement. We might talk about future functionalities that's not yet available. Here's the agenda. We'll talk about the history, once upon a time, and then we'll talk about the making of the Oracle R2DBC driver. And the main part of the presentation will be taking your code from synchronous to reactive. So once upon a time. So once upon a time, some of you have heard about the asynchronous database access API, aka ADBA. And we started this project in 2017, which is a long time in our industry. And the goal was to come up with an API, a new Java API for database access, which never blocks. That's the main thing, never blocks. And why do we want to do that? Because asynchronous API gives better throughput. You can do parallel database operations, you can fire and forget, etc., etc. So that was the main purpose. And you can still see the API at the link at the bottom of the slide. So the question is, why did we stop working on ADBA? And that's a good question. Thank you for asking. The problem is, we talked to the Java SC team at Oracle, the people who control Java SC, what goes into Java SC, what makes up the Java SC standard. And they told us that we are providing a solution to a problem that they already addressed with the project Loom. In other words, the future of Java scalability is Project Loom, also known as Virtual Threads, which is coming in preview in JDK 19, in case you have not heard. So that was the first argument. The second argument is we did not get a strong support from the community. So you guys were probably, already gravitating towards, R2DBC or some other API. Okay, then what? So what did we do? Well, we turned our attention to reactive extension in the driver that I will show you in a moment. And then we also focus on an Oracle R2DBC driver. And the guy who wrote that is with me on the call. So in a nutshell, we move from reactive, we move from synchronous, at the top, you can see that a chain of operations and they're all blocking. So you have to wait till the last element of the chain accesses the database, and then the result set will come back to you. So all those things are synchronous and blocking. At the bottom is the asynchronous part of it, where you don't have to wait. You make a call and it returns immediately, and you just collect your result set at some point. So this is a snapshot of the reactive extension in the driver. And we started this, it's in the JDBC, Oracle JDBC release DB21C. So it's already there, it's out there. And you can see here, we implemented the Java util concurrent flow API so that you return most of the time a publisher object. you can see most of those APIs return a publisher. Sometimes we got a subscriber, but predominantly a publisher. So you make a call and you receive a publisher. That's it, right? The call is done. And then you can use that publisher later on to request maybe result set or some other stuff. So what you can see here is that we sort of map the APIs to the JDBC APIs. If you're familiar with JDBC, you can see that this API is exactly, almost exactly the same. The difference is we prefix with async and postfix with Oracle. We postfix with Oracle in case the Java community loves our reactive extension and want to adopt it. And then in order to avoid clashes with our own API, we just put Oracle at the end. But the community is welcome to adopt this beautiful API. So, okay, I am not a developer, and the guy who wrote it is on the call, but I'll just give you a snapshot. So side by side, you can see a synchronous code and an asynchronous code using the reactive extension. Okay, so you can see that this code is divided in several sections. And is it pink? Yes, sort of pink or rose is the difference between those two codes, right? So you see that in the preparation, all those phases, it's similar. The only difference is when we process the result and get the result set. So the question is, when Michael was developing it, he separated out common things. And, so at the top of this slide, you see the difference between the synchronous and asynchronous. For time's sake, I'm not going to comment the code for you, but trust me. And he's going to comment more of that in the next session. So you can see that we mutualize, we mutualize the things that are common, and we separate things that are different. Okay, so what does that give you? Right, that gives you this this image, and look at this image. So from on the left, on my left, in blue, is your Java code business. I mean, it's a business logic. It's what the purpose of your Java code, right? And everything else on the right are the API, the library, the JDBC library, combined with, either the standard JDBC, which is at the far right, completely at the far right near the database. That's the standard JDBC API. Then a little bit on the side is this reactive extension. And in green is third-party reactive streams libraries, which can work seamlessly with the reactive extension, provided they support the reactive org types, that we can map to the Java flow types, which are the ones that are supported in the Oracle JDBC reactive extension. So if you look at this slide from the bottom to the top, you can perform synchronous operation as you always do with the JDBC, using your JDBC API. That's synchronous. And you go up a little bit, that's the reactive extension, where you have a reactive extension with flow, with back pressure support. And if you go to the top, where you are using the third-party reactive streams library, that's where you got the full-fledged reactive streams, with all those operators. You can see at the top left of the slide, you see all those, frameworks and things like that, monitoring, etc., which is the full-fledged reactive streams mechanism that are not available in Java util concurrent flow, which only provides you an interface. So we do implement the interface in the driver. So that concludes my part of the presentation. I'm going to turn to Michael. to take you to the next level.
Okay, so yeah, just to recap, we've talked about how we built these reactive extensions, which are just part of the Oracle JDBC driver. And now we're going to kind of keep going up the layers. And the layer above JDBC is Oracle R2DBC. So R2DBC is a bit like JDBC in that it's offering a standard interface that can be implemented for different databases. So we implemented one for Oracle database, but there's others out there for all the big databases, you know, Postgres, MySQL, SQL Server, many others. And we're all implementing this common interface. So your code doesn't need to have a dependency on these Oracle JDBC kind of proprietary methods, which are the reactive extensions. Instead, you can consume the R2DBC driver. So what we're showing on the screen here is just kind of how those reactive extensions map onto the standard R2DBC interface. Creating connections, executing statements, consuming results, commit, rollback, close, and then, of course, lob streaming. So working our way up those layers, the layer above R2DBC is you. It's your code. You can consume R2DBC. And what I'm going to go through in the next few slides is this kind of side-by-side comparison of what you would see on the left for JDBC with synchronous code, and then how to do that same thing with R2DBC for asynchronous reactive code. And I'll also note the link at the bottom of the page here. You can actually get all these code examples in one big file. And I encourage you to do that because some of these might require some time to kind of sit down and study to really understand. So anyway, first thing we want to do is configure our driver and tell it, how do I get to the database? So on the left side with JDBC, I use a data source. I give it the host, support, the service name, my user, and my password. And on the right with R2DBC, we have a builder style interface where I can set those same values. So now we're connected to our database. Let's go get some rows. So we're going to do a select query. On the left with JDBC, I get a result set. So there's our first blocking database call. When I call statement execute query, I'm making a call to a remote database, and that method is going to block your thread until I get a response back. And once I get that result set back, I can iterate through the rows. And if I have a lot of rows, those calls to result set next, those can even block your thread. And so what we do with our rows is we just extract a column value. It's a very simple example. I'm just calling getString to get the value of the first column. I'll move to the right side now for R2DBC, where I'm doing that same select query, except now I'm going to use this Flux factory, Flux from. So Flux is from a library called Reactor, which is, I can't say enough good things about it. It's a great library to help take these plain publisher interfaces and adapt them into something that's a lot easier to use. And the style they go for is more of a functional style. So we see that happening with these lambdas here. When I execute my select, I get a result object back. And I consume that result in this callback, which is under that flat map operator. And what I do with that result is I call its map method. And again, another function, this time transforming rows into that simple string value of the first column, just as we did with JDBC. So what's a flat map? Best way I can think to explain it is a kind of mathematical sense. So if you have a function that consumes a value of type X, and then it outputs many values of type Y, or a stream of values of type Y, well, then we can take a stream of X values, apply that function to each value of X, and we end up with many streams of many Y values. And what FlatMap does is simply kind of concatenates each of those Y value streams just into one big stream. Final thing I want to note about this slide, and this is new, we've added this to this presentation just recently. In the bottom left, you can see I'm calling this method you might not have seen before, executor's new virtual thread per task executor. This is part of Project Loom. And by calling this executor factory method, I can now run my blocking code on a virtual thread. And the beauty of that is virtual threads are very cheap. So if I want to, I can spawn millions of virtual threads, all just blocking for those database calls with the traditional JDBC API. So that's this query JDBC async method you see in the bottom left. You're going to see a variant of that for each of the slides that follow, just to demonstrate how simple it can be to adapt blocking code into asynchronous code and not having to worry about callbacks or anything else. So we've done a query to get some rows. Let's go add some more rows. We're going to do an insert. With JDBC, we call execute update. We block for the database to send a response back. And then we return the count of rows that have been updated. With R2DBC, again, I'm doing a flat map operation, and I'm getting that same result object, except this time, instead of saying I want to map rows, I just tell the result, I just want to get the count of rows updated. Now that returns a publisher, which is a stream of values. And so this is why I use the flat map operator to turn that one result into a stream of values. In this case, there is just one update count. So don't let that be too confusing. And again, we'll just note the virtual thread executor example on the bottom left. Pretty simple to take that JDBC code and run it asynchronously. So now we've inserted some rows. We changed our mind. We don't like the values we inserted. Let's go update them. This is very similar to the insert, though, where we execute update, get a count of rows back, and then the same thing with R2DBC, just like we saw on the previous slide. So, this next example is a little more interesting, because what I'm going to do with JDBC is I'm actually going to look at this update count I get back from a database. And then depending on the value, I might go do an insert. So I might go do another database call. Or maybe I like the count because it's not 0. And I say, let's just return it. So how do you do that with R2DBC? Because again, you have to keep in mind, we're doing this conditional, but we're doing it based on the result of a database call, which means we have to consume that result asynchronously and then decide what we're going to do. So again, it's going to be flat mapped to the rescue, where we're using a callback style to consume that update count, take a look at it, and then possibly do another database call, do that insert, or we like the count, so we just return it. This next example, it's similar to this if-else we just saw, except now it's try-catch. So we're going to try to do an insert. If it succeeds, great, let's return the value. Oh, if it fails, though, well, let's look at that failure. And if it's one we think we can recover from, in this case, if we violate a unique constraint, okay, well, the row's already there. So let's recover by updating the row. And we see that in the if-else happening inside of this catch block. But then if it's some other error, we don't know how to handle that. So we just throw it up the stack. Equivalent for R2DBC, again, thanks to Reactor, we have this on-error resume operator, which is very much equivalent to this catch block we see in the synchronous code. So with on-error resume, we can kind of catch that exception, take a look at it, and then we're actually doing a flat map here because we're going to return another publisher inside of this function. So if we see the error that we can recover from, we return a publisher of the update with update R2DBC. And then if it's another error, return this other publisher that just emits the error. Final example I'm going to show is a loop. Personally, I found this one the hardest to figure out for the reactive style. But just to introduce it, with JDBC, we have a do while, and it's while true. So we're going to look for some condition happening inside of this loop that tells us, okay, it's time to go, time to exit. We're going to return or we're going to throw. And you see those two statements on the left side. So with reactive, it's not as simple because I can't just call try update R2DBC. I can't just call that in a loop because remember, I have to get a response back from the database before I know if I can exit the loop. I have to know that the call succeeded, or I have to know that the call ended with a particular error that I can't recover from. So I can't really use do while here on the right side with R2DBC. The aha moment here for me is recursion. It's not classical recursion in the sense of what we might do with a synchronous style, searching a tree or something. But if you look, this method is loop R2DBC. And if you look in this on-error resume operator, the very bottom, last thing I do is I actually just call myself. And in this way, I can kind of emulate a loop where I say, I'm going to do this database call. I'm going to wait for a response to come back. And if I think I can recover, I want to retry. And so I just kind of return myself. And that becomes my flat mapped publisher. Again, notice the GitHub link because this one is a little tricky and you might want to study the code to really understand it. So yeah, now we've gone all the way up this stack with all this technology, and we've seen the final layer, which is your code. And hopefully this helped to kind of show you how, okay, if I know JDBC, maybe I can do the same thing with R2DBC. But throughout all this, we've kind of shown you two ways to do the same thing. We've said, for scalability, you can use reactive code, which uses non-blocking calls and spares you having to allocate a ton of block threads. Or you can use virtual threads, where they say, go ahead and block me. It's fine, because your system can handle millions of us being blocked. So which pill should you take? Well, we say it's up to you. The Oracle JDBC team sees that on both of these solutions, virtual threads and reactive, very talented people have put a ton of effort into making these solutions as good as they can be. And so that's why we support both of them. So if you want virtual threads, the Oracle JDBC driver has been, in quotes, virtual thread compatible since our 21.1 release. What that involved, this compatibility, was replacing what most people know as synchronized methods or synchronized blocks. We replace those with reentrant locks from the Java util concurrent locks package. And the reason we did this is if you enter a synchronized block and you do some kind of blocking IO, like with a database, virtual threads can't really handle that so well. There's reasons for it. I am not so familiar because I am not developing virtual threads, but we just knew as library maintainers, our responsibility is to make sure we're virtual thread compatible. And so we've done all that work and it's been ready since 21.1. Now, if you want reactive, we support that too. Oracle R2DBC just had its first major release, 1.0. And if you don't like R2DBC, you're welcome to just consume those lower level reactive extensions directly from JDBC. So not to dodge the question at here and here, we do believe both solutions are really great. And we think the best thing we can do is just show you, here's what we think the benefits and limitations of each are. So the benefits of virtual threads, the biggest one is synchronous code is easy. We all know synchronous code. We all know how to read it. We all know how to write it. That means maintainability costs are going to be minimized. If you have existing code that's synchronous, it's pretty easy to adopt into virtual threads. As I showed in those examples, all I had to do was create my virtual thread executor and then just submit my synchronous code onto it. The one caveat, let's keep in mind, is make sure you're not using synchronized. No synchronized blocks, no synchronized methods. Other benefits of virtual threads, easier to debug, right? You just step into stuff with your debugger, it returns the result back. And it just kind of integrates a lot better with some JDK tools like mission control is one. Now, what does Reactive do well? Well, for one, it's available right now. If you're on JDK 11, that's our minimum requirement for Oracle RTDBC is to be on JDK 11. Then you're all set and you can use it right now. Whereas virtual threads they're on their way. They're a preview feature right now, but they're not really available in an LTS JDK right now. Another great thing about Reactive is this wonderful ecosystem of libraries that have been built around it. So Reactor, Arcs, Java, Spring, I'm just naming a few. These libraries give us this nice stream-ish kind of API, and we get to write code in a functional style, which a lot of people like. And one thing you don't really see, though, because it's happening behind the scenes, these libraries are handling a lot of this low-level concurrency stuff, locks, atomics, queues. That's all just being extracted away behind this, like a Flux interface with Reactor. So some limitations for virtual threads. As I mentioned, it's still a preview feature in JDK 19. Obviously, as time marches forward, it will make its way into eventually not a preview feature, and then eventually an LTS JDK. The other limitation is some libraries, as I've mentioned, they might not be compatible due to using intrinsic locks or AKA synchronized blocks and methods. So if you have an older library, you might need to update it. And if you know a library maintainer, you might want to mention, hey, virtual threads are coming. Make sure you get those synchronized blocks replaced with a reentrant lock. Last thing is the limitations of Reactive. Steep learning curve. It took me months before I really felt like it clicked, and I felt like I can solve any problem I want with Reactive. A lot of hard work to get there. And then once you get there, all this code you're leaving behind, other people are also going to face that curve, and so it's going to be harder to read the code and probably harder to update it. And last thing I'll mention is debugging, more difficult with Reactive, especially this part about result processing happening on an asynchronous thread. You'll need to drop a breakpoint in a calculated manner and make sure the debugger knows when to stop because this other thread somewhere is calling your callback. So in short, it's harder to debug. So thank you. I hope this was helpful. Kuassi, why don't you sign us off?
Thank you very much. And we encourage you to embrace Oracle JDBC with or without featured thread or reactive extension.